off here, and. So that's how wireless technology works in the first place. And now, if you're going to use wireless technology, you have the issue of authentication. Since the users are mobile, you do not know where they are, the way you might if they're using these heavy desktop machines that might be tied down. So you want to find out who they are. And there are various ways to do this. Now, home users typically use a pre-shared key, which is an insecure procedure called a shared secret. You know, it's kind of foolish. Once you've shared a secret, it's not really a secret anymore. So you have a password, you type in your router, and if you change that password, you're going to have to type the new password in all your devices. So this is for the birds, because at a company, you have new people coming in, and you have people getting fired. And when you fire someone, you want to cancel their account, but you don't want to make everybody else change their password. So use a better system like 8021X for this sort of thing. Anyway, 8021X can use a variety of authentication protocols, from very weak ones to very secure ones. So point-to-point protocol is what lets you connect two people at one and authenticate them. And this is what was used for DSL modems and such, where you can just send some kind of password up the line so they can verify that you paid your bill. In the earliest cases, they would just send unencrypted passwords straight down the line, which is not as terrible as it sounds, because you would have a wire going up to the internet service provider. Anyway, that was password authentication protocol. In order to improve that, as we started using shared networks, people switched to CHAP, where the server would send a challenge, which is just a few random characters. Then you add it to your password and hash it, and send the hash up the wire. So the thing on the wire proves that you know the password, but it can't be trivially sniffed to learn the password. All right, that's CHAP. And that's vulnerable to passing the hash, because what I can do is, if a user is over here authenticating to a server here, and I can get in the middle, the server sends me the challenge, I take the challenge, pass it on to the client, please send me the right answer. They send me the right answer, I send the right answer up. And now I'm in. Because there's no trusted third party, it's subject to a trivial man-in-the-middle attack. All right, extensible authentication protocol is the improvement here, and now you can use real strong cryptography, like Kerberos, which is what Microsoft uses in Active Directory domains that came from MIT, where you send cryptographic tokens up and you get a ticket that gives you 10 hours of connection to a server, and you get a different ticket every day, and so on. It uses tickets and keys. Then you can use certificates, like HTTPS certificates that are used on the web, that prove who you are with long cryptographic responses that cannot be forged. So X509 is the standard for HTTPS that defeats man-in-the-middle attacks, and the reason it defeats man-in-the-middle attacks is because you have a trusted third party, which is the certificate authority. So if you connect to Gmail, Google will give you a certificate. And by the way, now everybody's secure, even AOL. I used to use AOL as my insecure connection in my projects, and even AOL is encrypted now. So, although I bet you they do it wrong. In fact, let's check it out. If you do View Developer Tools, we can see if AOL does it right. And I have been using them for years as the example of everything being wrong, so I bet they're still wrong. Let's see. Now I go to AOL.com. I was going to go to HTTP. Well, I'll do it the easy, AOL.com. Okay, I go to AOL.com, and let's see what happened here. The important thing is what the first network requests were. This is what I thought. I knew I could count on AOL to do it wrong. Okay, take a look at what happened here. I sent a request, and I should be able to see the raw headers. Okay, I sent a request to http AOL.com, which was not encrypted, and I got a reply, moved permanently down here. Yes, 301 moved permanently. So what happened is I made an insecure connection to AOL, and then it told me, no, go over to the HTTPS page. This is completely a waste of time. This means I could have just put up a fake, insecure AOL page that doesn't send that response, and I can totally see AOL passwords. This is the wrong thing to do. The right thing it should have done is return a different error message with an HSTS header, which says, this is a secure page. Do not load it this way. Go start over and load it securely. That's entirely different. And anyway, but that's the game. Now AOL is secure. So if you do not get fooled by the redirect stage, which is insecure, and you end up at a secure page, you're now secure because you have a certificate. And you can learn more here. Some places get rid of that. Somewhere is the stinking certificate. Where have they hidden the certificate? View certificate, dude. All right. Used to be right here, but they keep moving stuff around because they're evil. I do not know how to view a certificate anymore in Chrome. How annoying. Does anybody know? Let's see what idiocy they've done now. How to view. It used to be the padlock, but they took that away. And there used to be that little thing there, and they took that away. Chrome. Let's see if there's any page that is not old. Options or settings under the hood. Show advanced settings. You're kidding. Okay. Am I supposed to believe that? Options. Settings. Okay. View. Settings. See, now I'm on some other page. All right, let's try a browser that has not decided to make everything impossible, like maybe Firefox, and see if someone will let me show you a certificate. They used to be right there, and these idiots have decided to hide it for some reason. Okay, here's the secure page. This now has the padlock. Okay, this is the way it used to be. You can click there, and it will show you the certificate. Something's wrong with this page. Your connection is not private. More information. There's the certificate. Okay. Firefox has not yet decided it's wonderful to hide this from you so you can't see the certificate. Now, to be fair, most users don't understand any of this and it just confuses them, so that's probably why they make it really hard to find. But anyway, this is what's actually going on. This certificate is issued to a site called Cloudflare SSL. Here's the fingerprints, which is SHA-256 and SHA-1 and a period of validity. And the reason they don't like this is because it's not really tied to my name. It's a Cloudflare certificate. But anyway, that's where you can see and this is where a trusted third party has vouched that they know who you are. So if I go to AOL.com here, I ought to get a good certificate. Yep, and with the padlock there, I'll be able to find out what's going on. Stop messing with me. There, more information. There, here's the certificate. This website is verified by Entrust. So Entrust is the trusted third party. And the reason I believe this is really AOL is because Entrust said they were. And I trust Entrust because the people that made my browser, Mozilla in this case, hardwired Entrust as one of the 100 or so trusted authorities. So if any of those trusted authorities say it's this company, it is. This is a problem because all you have to do is put yourself in the middle, which is easy to do. For example, if you're a nation state, China does this all the time. They put out false BGP packets to take American companies and reroute the traffic to go through China and then back to America. Now they're in the middle. Now they put up a fake HTTPS certificate and sign it by the Chinese government. The Chinese government is on the list of trusted sites. It has to be, or no Chinese sites would load. So, and your browser, the official algorithm used for HTTPS is does the domain name on the certificate match the domain name in the browser? Well, it's AOL, and it does. Is the valid period? Is a date in the computer in a valid period? It is. The third thing is the certificate from a trusted authority? And it's all or nothing. If they're on the list, I trust everything they say, and I trust no one else. So they don't mind at all that Google is being signed by the government of China today. Oh, that looks fine to me. So in order to fix this, people have come up with various non-standard solutions. The best standard is, I think now, HSTS, which I think now is an IEEE standard, where you can put a header in your response that tells people this page should be secure. And what Chrome has done to solve the other problem is they put a list of the top 1,000 websites in the browser, and Chrome knows whether they should be secure or not. And I think they also know who should be signing the certificate. The best cure is certificate pinning, which should be used in mobile apps, although almost no one is doing it. The technology exists whenever the developers bother to use it, where you put a key in the mobile app so it knows not only that it should be signed, but which company should sign it. And now the mobile app knows that your company should be signed by VeriSign. If it appears to be signed by somebody else, don't fall for it. This is important because a lot of people can get fake root certificates. Not only governments and nation-state actors can do it, but anybody with enough money can bribe it from American certificate authorities. It has been another of these open secrets in the industry and leaked out very clearly about 4 years ago that almost all the certificate authorities will sell you root certificates for a large enough bribe so you can pretend to be them. And corporations do this at the edge of their networks. They man in the middle of the HTTPS so they can check all the traffic. So that's the problem. HTTPS is a very good mathematical solution, but nothing can really overcome human treachery. When people lie to you and betray you, then all your math doesn't save you. Anyway, the point here is the certificate sends you a public key. And with the public key, you can encrypt data so nobody can read it except the holder of the private key. So every company has to have a public key that they send to everybody and have a private key that they have to not lose. So the company has the problem of keeping the private key and backing it up so they don't lose it from server failure, but not letting hackers steal it. So this is the public key for Google at this time, was 1120 bits showing up there. And anyway, that's considered the most secure system on the internet. HTTPS, the most secure version based on prime numbers. RSA cryptography, we'll have a lot more about it next semester in the crypto class, and even in another chapter in this class, we'll have more about the details of the math. The math is very good and considered unbreakable right now, but about a year ago, the NSA scared everyone to death by announcing that quantum computers are really coming, and they will greatly rock the boat, and almost all the protocols we trust today will be broken in a hurry. So things will have to change. And what they're currently recommending is to make the keys much longer, like 3 times longer, to hopefully survive even the onslaught of quantum computers. Anyway, LEAP, when, like I say, WEP came out, and everyone rapidly figured out that it was unsafe, and the IEEE was not there with a better standard. So manufacturers invented their own improvements on WEP, and Cisco invented LEAP, Lightweight Extendable Association Protocol, Authentication Protocol, and it turned out to be subject to an offline dictionary attack, and Joshua right here was the hacker that wrote a tool to crack it. And as usual, once you prove that something is insecure, you get punched in the face for it. Cisco's statement that what this guy did was turn a theoretical threat into a real tool, and therefore he laid waste to millions of dollars of investments. Now, this is an interesting perspective. It's not that Cisco made a defective product and sold it to a bunch of suckers. The product was perfect until someone built the hacking tool, and that's the guy that ruined it. This is the classic response of all authority figures, is to just shoot the messenger and blame the messenger for telling you that you made a bad product and just carry on. And as long as the customers don't find out your product is bad, everything's fine. It is disturbing, and this never stops. Every company always responds this way to all security bulletins for, in my experience, about 10 years before they wake up and realize they can no longer fool their customers, and they actually have to admit that security problems will come and you patch them, and you can't pretend to be somehow above all that. And Verizon announced that these guys were narcissistic vulnerability pimps, the people who made a hacking tool later. This is what you typically get. So these guys made t-shirts that said narcissistic vulnerability tips and wore them to DEF CON. This is the best thing to do when people insult you, is put it on t-shirts. I found it helps. Anyway, so there are more secure methods. There's one usually TLS, which is fine, really quite fine, but you have to pay for certificates at both ends, and that expense has held people back. Now it's been about a year since the EFF has been giving out free certificates, so if that continues, this kind of protocol might become more popular and everybody can afford them. Then Microsoft has PEEP, Protected EAP, and Microsoft PEEP, and those are considered quite good, and they only have a certificate at one end, so it's more affordable for the company. Anyway, 802.1x is the protocol that lets each person join your wireless network and prove who they are. So the way it works, you have a supplicant, is someone trying to join, then they connect to the access point, which is the authenticator. Then the authenticator collects some kind of data from them, like a name and password, and sends it over to the authentication server, which has a database of acceptable credentials, and it tells this whether you made it in or not, and if you did, then you're allowed to go to the corporate network, and if you didn't, then it kicks you out. So that's just typically a radius server, although a more modern alternative from Cisco is TKIP, just a system of sending credentials over a network. And they could be very weak, like just MAC addresses or passwords, but they could be strong like certificates. There are various different versions of this. But they all have the general feature that it's relatively expensive for a home user because you have to pay for another whole server, so they don't typically use it. But it's used at companies because every person has their own credentials, and now you can hire a new person to give them credentials, fire somebody and revoke their credentials without affecting everybody else. And that's what you need at a company, but you typically don't need it at home. So WEP was the original encryption protocol included in 802.11b. It had a lot of vulnerabilities, and we used to crack it for homework in class. It's not worth it anymore because you almost never see WEP anymore. WPA was the rapidly created temporary upgrade that in fact turned out to be much better than anybody thought and never get cracked. And TKIP was Temporal Key Integrity Protocol. All WPA is WEP, where you keep changing the key for every packet. But that turns out to be enough. so you can't collect enough data to crack it. It has a few other improvements. It also has message integrity checks, so you cannot record a packet and replay it, which you could do in WEP. That was part of the efficient way to crack it, was to record an ARC packet and replay it a million times. And it has other things. There's an initialization vector that's added to each packet before encryption, and they made it longer because that was one of the problems with it. And a couple of other tricks. But those are the 4 band-aids that fixed over the 4 biggest holes in WEP and turned out to be good. WPA also had the ability to play this 802.1x game where everybody has a different key and it's all stored on a radius server, which they didn't think of WEP. WEP was a protocol designed only thinking of home users. So now WPA 2 is just an improvement of WPA, where they just replace all the components in WEP with the really modern improvements, more modern encryption standards and such. It's considered faster and more secure on modern hardware, but both of them are perfectly fine. If you're using a network using WPA and you choose a key that is not easy to guess, nobody's getting in there without the key, not through the mathematics. Now, there are other flaws, typically in routers, where you can take over the router, but the mathematical part of it, the encryption, is perfectly fine in WPA. I mentioned before, pre-shared key is the home mode where everybody has to type the same key in every device, and that is typically only useful for a home network. For a business network, you use 802.1x with an authentication server, so each employee has their own key. That's better in the more complicated, rapidly changing environment of an enterprise network. There were a couple of WPA attacks developed in 2008 that would let you, under certain conditions, replay a packet a few times, but this did not turn out to actually lead to any major crack. At first, people were panicked. Like I say, they always thought WPA would only last for a couple of years before somebody hacked it like WEP, but that never happened. There is no tool you can get that will do anything very effective to hack into WPA. There's a hacking tool, I think it's included in Corley, called Cowpatty, but all it does is a dictionary attack. You give it a list of passwords and it tries them all. That is an attack that any password-based system is always vulnerable to, so you have to choose passwords that aren't easy to guess. But there's nothing faster. Unfortunately, this was all ruined by a technology that came out in about 2006 called WPS. When I heard about this, Microsoft touted this in their manuals as a security improvement. And the reason was this. If people have to choose their own password and share it at home, they will choose an obvious password, like home network or something. Then they have to type it in every device. And since their devices are cell phones with those little screens and stuff, they have trouble typing it. So they're probably going to choose a simple password and never change it. So WPS will automatically create the password and automatically transmit it to devices. You can carry it on a USB stick. You can even send it by radio once. So when I heard that, they said, this will be much better because now the password will be a long random string. And that sounds fine, but that's not what they did. What they actually did was choose a password that is 8 digits, and that's it. And they didn't even use all 8 digits. What they did was choose a password that's composed of 2 4-digit strings. The first 4 digits can be anything. The next 3 digits can be anything, and the last one is a checksum determined from the last. So the total number of possible pins is 10,500, which is not enough at all. So there's a tool called Reaver, included in Backtrack and Corley and everything. You can run it and hear how to router, and it took 19.5 hours and just tries every pin and gets in. So they destroyed the security of WPA and WPA2 with this distribution technique, and if you want to be safe, you have to prevent it. This is why if you replace the firmware on your router with Linux, you will not have this feature. Cisco takes the cake here. Cisco devices would let you turn off WPA, WPS, which had the effect that means you can't use it, but this attack still works. They don't really turn it all the way off. So that is really rude. So anyway, that's very annoying. WPA and WPA2 were fine, and WPS made them worse than WEP, or as bad as WEP, where you can get in with no information at all. So if you do have WPS, you probably want to turn it off, although to be fair, this attack is pretty impractical. Cheap routers, when I tried this, I had to buy like 4 or 5 routers to get it to work. Any router I found for less than $80 is so poorly built that it crashes after about 10 guesses. So unless the network administrator is willing to reboot the router about 1,000 times without feeling like something is wrong, you're not going to get in. Many routers have a proprietary measure, non-standard, added by the manufacturer because the router software manufacturers were able to say, that pin looks pretty short. So they've often put in non-standard rules of like only 5 guesses before it stops you or something. And so the only thing I was able to actually successfully attack her was a router that I think cost $150. It's the only router strong enough to actually withstand this attack. And it still took 19 hours. So it's not too practical, but it certainly makes your security much less than it would be if you just had plain old WPA2 without some poorly thought out convenience feature on top of it. So wardriving is where you just drive around to try to find all the networks to find something to attack. You just drive with a laptop computer running wardriving software, or use a car or a balloon or a bicycle or pretty much anything. We used to do it every semester here. We did it for many years until the results stopped being interesting. We did it from 2008 to 2015 until it got to the point where 80% of everything was WPA2 and less than 1% was WEP. When we started, half the networks were WEP, and there was some usefulness to this awareness that these guys should fix their routers. But what happened, I think, is not that people got smarter, but that people just threw away their old equipment and bought newer equipment. But now there's essentially no WEP out there. And here, there's really only two categories. There's WPA or WPA2, which is perfectly fine. And then there's open, which is also perfectly fine, because those people might be coffee houses that really intend for the whole world to get in, or more likely, they are walled gardens, or once you connect, you will now have a page where you have to put in a credit card number or something. And it is by design that the first step is unencrypted, but there's another barrier beyond that. So the number of people that are just doing something wrong is just the red ones. All WEP does is make you think you've encrypted the network when you haven't really. And so there's no real need. So I took out the Wardriving project and I took out the WEP-Cracking project. If you go to the old classes, you can see those attacks if you want them. They're kind of fun projects, but they're really no practical importance anymore because there is no WEP out there to mess with. So you drive around with an antenna, you sniff this stuff. Some of them just pick up the SSIDs that you pick up from networks that are beaconing traffic. If you get Kismet on Linux, it picks up all the networks, even the ones that don't have beacon frames, by picking up other traffic. But anyway, this is what the Google cars are doing. They're driving around everywhere. They are taking pictures of the street, and they're also sniffing all the Wi-Fi networks, because this is how Google identifies your physical location. GPS signals can identify your location down to inches, but that is only for the military. Then they use it to target cruise missiles. And since they don't want amateurs sending out cruise missiles, they deliberately add, I think, 50 yards of randomness to it, so that you can only get like within a block of accuracy from GPS. So in order to get your driving app more accurate, they use the Wi-Fi networks to detect it. And they have a huge database that Google creates from those cars of where all the Wi-Fi access points are. So NetStumbler was one of the first ones people would use just to find unencrypted networks to connect. It would just detect access points and tell you if they were encrypted or not. It looked like that. You could drive around and connect it to a GPS. And Kismet is the better tool that runs on Linux that gives you a lot more information about wireless networks. And so when you connect, if you connect to a wireless network, then you can just do the same thing you did with a wired network, port scanning, enumerate servers, find weaknesses, and get in. AirCrack NG is the popular tool for cracking wired equivalent privacy networks, if you find one of them, but this is an artificial thing, not that common anymore. The Wi-Fi Pineapple is a popular tool. You pay for this thing, and it automatically puts itself in the middle, and then tries to spoof networks to get people to join, and tries to trick them into downgrading unencrypted protocols and steal their password, and does such various things there. It's considered a sort of script kiddie tool. It does all this automatically, so it's fun, and you don't even necessarily understand all the attacks it's performing. If you want to prevent these things from happening to you, you could put up fake devices to attract attackers. That's something people did occasionally, although I don't think it turned out to be terribly effective. This fake AP tool didn't turn out to be that useful after all. Would pretend to be other access points. You can put metal containing paint on your walls so the wireless signal stays in the building and doesn't leak out very much, and that will prevent people from detecting your network from the outside. You can have MAC address filtering, which is something people mostly do at home. If your neighbor is losing up your bandwidth, you can filter it over only known MAC addresses. It's a very weak authentication measure because the MAC address is sent unencrypted in every packet. So all they have to do is run Wireshark and they can see the approved MAC addresses, but your neighbor might not know how to do that. So I used to do this when I would go to a crowded coffee house, and I just wanted to run my network unencrypted so it would run faster, but I didn't want other people joining. I'd do MAC address filtering, and it may stop casual people in a coffee house, but it's not going to stop anybody that's taken as much as maybe 106 of training. You can use an authentication server like 8021X, and then only people can only get in if they have valid credentials. You can use one of these EAP authentication protocols. Some people say the longer version of WEP is better than the short version. They're both pretty worthless. That's really a pretty weak measure. One thing I see a lot of is machines that turn off DHCP, so you have to know the address to join. This is as useless as MAC address filtering if you just turn on sniffing, you can see other people's network addresses and find out what the range is, and then just assign yourself a number in that range. Like not broadcasting the SSID, these are very weak measures that just stop the weakest attackers. In any case, one thing to know about your wireless network is it is intrinsically insecure. The people that come in over the wireless network should be considered not very trusted, and you should put them in your DMZ, where you put people from the internet. You shouldn't let people in the internal network without making them pass through another security test to make sure they really are employees. And I say there's there's a video here if you want to see how to change your MAC address. It is so easy, it'll make you sick. All right. And one thing I didn't see there that I ought to point out is Wiggle. I thought I had it in my slides, but this is the modern replacement of NetStumbler's Wiggle, Wireless Internet Geographic Locating Engine. You can put this app on your phone, and people do everywhere, and they are just mapping out the whole world and putting all the access points on it. So I should be able to get to 50 Phelan Avenue here. Yeah, 50 Phelan Avenue, San Francisco. All right. This is all the networks constantly updated by everyone. You can put it on your phone, you can put it on your laptop, you can upload your data and share it. This is crowdsourced Wardriving. And so here we are, there we are. There's City College, and here's CCSF Wi-Fi, and here's Sprint and Guest. And if you go down to the street around here, I should be able to shrink this down if I can figure out how to, there we are, maybe this, yeah. There's down, someplace down here is Ocean Avenue, and there'll be a, there we are. There's a lot of them on Ocean Avenue, as you would imagine. Where?
McDonald's on Ocean. McDonald's on Ocean.
Yeah, this is about where I am. This is about near McDonald's on Ocean. Here's the gas station. And as you can see, they've just found all the networks everywhere. And when I first heard about this, I was sort of surprised because people keep buying a new router, moving and changing, so they have to keep refreshing this. And this is refreshed by amateurs. Google does it by drivers they pay. Everyone has to keep a pretty accurate list of all the devices out there. Notice the MAC address is just right there. And there are search engines where you can look. So this is actually an interesting privacy issue. Every time you boot up an iPhone, it tries to connect directly to the last 5 networks you were on without going through DHCP. So it broadcasts the MAC address of the last 5 routers you connected to. So if you want to stalk somebody, just sit in a coffee house when they turn on their phone, and you will get the last 5 MAC addresses they've been at, and you can Google them and find out where they are. And you will find their work, the other coffee house they like, their home. It is surprising. It has been known for about 6 years, and Apple does not seem interested in fixing it. But it is a considerable stalking risk, I would think. Anyway,
how current is it?
What's that?
How current is it?
This one is crowdsourced, so it's just going to be how many people like to run this app on their phone, and I do not know. Google updates their stuff pretty often, though. And there's a company called Skyhook that generates this data and sells it, and they will probably tell you how current it is. I don't really know. I know in practice, Google Maps is very good. When a business moves, I notice Google Maps quite quickly moves it to the right place. Apple Maps is fantastically bad. Apple Maps is like 10 years out of date. If I go to places I know, they've got stores where they used to be 10 years ago. And they often travel to drive-through parks where the road doesn't go anymore because their data seems to be 10 years out of date. Yeah.
Is the pictures and I guess the business, are they matched? Because there's a privacy issue on the pictures, right?
There is a privacy issue on the pictures. I've never heard of someone saying, take my Wi-Fi out of there, but I bet you could. I bet you could complain to Google and say, take my access point out, and they would. Yeah. No, not at all. It's crowdsourced by people going by. It's historical, but it seems to be pretty up to date. That's why I think the algorithm has to be, if I connect to 10 access points and I recognize 8 of them, accept that, because I'm sure some of them have changed and the data is not up to date. But it is very effective. The end result is they can really locate your car very well, which is what they're doing it for, to physically locate you by triangulating from the access points around you. And it is interesting, and I know when Google tried to take Google Street View to Japan, they kicked them out of the country immediately, because in Japan, they went down the street taking pictures of houses, news-walking houses, and people complained. They had a concept of privacy that said, you can't do that, I'm not putting up with that, this is outrageous. Americans did not have that response at all. Very few people cared. They figured if it's out on the street, anybody can take a picture of it, and that's okay, but that did not work in Japan. So privacy is a very cultural thing. Anyway. So I got a few iClickers. Let's see, I should have the sensor here. Okay, good. So, which protocol sends passwords with no encryption at all? is something you almost always find at any company when they hire their first security engineer, is they're doing a bunch of things that are incredibly stupid like this, and that is your first priority to fix. We had some plain text authentication here on campus until about 5 years ago. There was a time when everybody thought it was okay, and everybody has some legacy equipment from that time, and it takes a while before you fix it. And that's PAP on this list. There are many lists, but PAP is the one with no encryption at all on that list. All right, which one is a proprietary Cisco system with known vulnerabilities? To be fair, serious known vulnerabilities. Pretty much everything has known vulnerabilities. All right. I'll quit at 30. All right, that was LEAP. And Joshua Wright wrote ASLEAP, which I think you're using in the projects to break into PBTP. I added it to one of my courses. It's a pretty cool tool. It can break into quite a few supposedly secure networks from maybe 8 years ago. Which one of these is the least secure? All right. I'll quit at 30. All right, MAC address filtering is the worst because this is like the coffee house where the password is just sitting on the wall in a sign. It's a password that's transmitted in every packet. No encryption at all. You just have to sniff the network and you find the password. WEP is weak encryption that you have to crack. The rest all have some degree of encryption. This has no encryption at all. It is just like hiding a key under the mat. The password is in plain sight for anybody who knows how to look for it. All right. How about this one? Which one of these is dangerously unsafe? Or more than one, to where you shouldn't be using it. Oh, crap, I'll quit at 30. All right, and that's the last answer because the first two are both broken to where they expose your data. WPA and WPA2 are fine, but both of those are too dangerous to use. All right, what's the best wardriving software that will find the most networks if you're driving around hunting for them? Quit at 30. All right, and the best one in the business is Kismet. In principle, Wireshark gives you complete data, but it's a real pain because then you have to dig through it all. Kismet will find all the wireless networks most efficiently. Anyway, I'll stop the recording and see who got the most right, and I'll go up to the lab and help anybody who wants help.